Hello there guys, I am Lewis. I'm going to be your youth tutor for today, as you can see by my sweater right here. As you can see, it is a beautiful blue sky in a very lovely autumn that we're having so far. And today I'm going to be doing some C3 differentiation with you. If you want to follow me, I can take you to the whiteboard. This exercise should help you out with when you're working with graphs, with radian measure, and just sort of general sort of differentiation really. So if I can work through it with you and we can have a little look.
Okay, so we're doing differentiation of trigonometric functions.
Yep.
4 parts to this question, it looks
Four
like,
parts
Lewis.
to this question, yeah. It's a quite long-winded question, but we can work through it quite easily. Question 1 is obviously, as it says, differentiate y equals x cos x.
Yeah.
In doing this, we're going to be needing to use the product rule, which is something we need to be learning. So if I write this in, it's going to be dy over dx equals, and then it's going to be u dv dx. And then to do that, then you also go plus v du dx. That's not x.
Yep, that looks
so
good.
that there is the product rule.
Which one's u, which one's v?
Yeah,
please?
so I'll put in here, so I'll put the x, I'll make that u.
Yep.
And then I'll make the cos x here v. So we can almost separate it up almost, just by, if you imagine it like that. And then you can input that then into the product rule that we've got here.
Okay.
So then I'll just put it in. So it's u is obviously, as we've got here, is x. So we've got x, and then we've got the differentiation of v, which you need to learn, which is so it's the differential of cos x is minus sine x.
Excellent.
So you put that in there. Plus v, which we've been given, so that's cos x there. And then the differential of x is just going to be 1.
Yep.
Because 1 times 1 is 1, and then obviously that there is to the power of, it makes it down to the power of 0, and everything to the power of 0 is 1.
X to the power of 0 is 1.
And then you basically just sort of expand the brackets, so that's it's going to be minus x sine x plus cos x. And then you can just simplify it a little bit.
Would you rewrite it? So
yeah, that's also just, so you go cos x minus x sine x.
That's perfect.
So
would you write it as, would you put dy dx in front of it and then underline it in red, please? Because that's your answer to the first part. Yeah?
Yep.
Which is very nicely done. With a flourish, indeed.
And then what we can do then is then you do the second part of the question, which is find the gradient of the curve y equals x cos x at x is equal to pi. Now we've already worked out here the differential, so now all we really have to do is just input the x is equal to pi into this to find the gradient. So we've already got this, so the dy dx is equal to cos x minus x sine x, and then that is at x equals pi. So therefore that is equal to cos pi minus pi sine pi. Now in this question we've been told not to use a calculator, so if you come over here I can show you how we can now work out this next bit. I've sort of took the liberty of drawing out a small graph so we can draw a sine and cos graph. So I'll do a quick sketch of a sine curve. So that's a sine curve, a quick one. And then here is a quick sketch of a cos.
Would you go over one in blue or something,
yeah,
and maybe label them, please?
Yeah, that's not a problem. I'll do that, shall I?
Yep.
That's
great.
You can tell, but this has gone blacky red.
Yeah.
Not quite.
Would you put an arrow pointing to the cosine, from there to the cosine curve, please?
Yeah.
That's the cosine one.
Yep. And then that is equal to sine. So
yeah, you can see there's a slight difference in
see
colour
there's a
there,
slight
just
difference
about,
in colour. So from this now, over here we've got cos pi, So on the cos graph, we need to find where it is equal to pi, which is at this point here. So that means cos pi is equal to -1.
Excellent, yeah.
So I'm just going to quickly write this over here.
So cosine pi is -1.
So that there, I'm going to just draw a little arrow, is equal to -1.
Yep.
And now we've got sine pi. So if we find on the sine graph where sine is equal to pi, we can see here it is equal to 0.
Brilliant.
So we go back over here and we can put that in. So that there equals 0. So now if we now we know this, we can put it back into the into what we've already learned here, which is, so that means it's equal to -1 minus pi times 0. Obviously pi times 0, like any number, is obviously going to be 0.
Yep.
Which means that -1 minus 0 is just going to be -1. So that there is.
Can you put that equals gradient, please?
Yeah, no problem. I'll just underline it in red as well. And then that equals gradient.
Brilliant.
Cool. Is that okay?
That's looking good. I think we'd better lose that red pen there. We'll work out blue or something from there.
I'll go to green. I'll go to green.
Okay.
Okay, so now we've been asking part 3 to find the equation of the tangent to the curve y equals x cos x at, again, x is equal to pi. So this here is using y equals mx plus c.
For the equation of a straight line,
For the
yeah.
equation of a straight line, exactly. So I'll quickly write that in here, just so we don't forget. And then...
And we know m, don't we?
Yeah, so I mean, we've obviously just worked out m down here, so that's equal to -1. So I'll put a little tick above that because we know that. X we also do know is equal to pi. But the other things obviously we don't know is y and c. The easiest one for us now to work out is y, because we've been given the initial equation here, which is y equals x cos x. So I'll quickly write that in here. Y equals x cos x. At x is equal to pi.
So we can rewrite
so
that.
that is equal to pi cos pi. And then obviously, as we worked out in this question here, cos pi is equal to -1. So therefore, y is equal to pi times -1, which is just minus pi.
Yeah.
Very, very simple. So now we've also got y. So now we can input that into this equation here, and we can work out what c is.
Okay.
So minus pi. So I'm just going to drag this down here. I've done the green pen so it's clear. So minus pi is equal to -1 times pi, is that correct?
Yeah.
Plus c. So minus pi equals minus pi plus c. And then you can obviously just rearrange the equation, so obviously minus pi goes on the other side, and that minus pi plus pi is going to be equal to 0, therefore c is equal to 0.
Excellent, yeah.
So I'll put that in there, c is equal to 0. So, I'll do it quickly as well,
so now we can rewrite the y equals mx plus c.
Exactly that. So now we can put here, I'll just do that.
So this is
so y equals mx plus c, so now that we know that y is obviously minus pi, but c is equal to 0, so we're just going to write it as y equals minus x.
Because we're using y equals mx plus c, m is -1, c is 0, and this is the equation of the tangent.
Precisely.
Can you just put tangent underneath it, just and underline it? Yeah.
So I'll put equals tangent.
Yeah, that's great.
And then that is obviously the equation of
and
tangent.
is part 3 sorted.
At that point, cool. Moving forward. Moving forward to part 4, find the equation of the normal to the curve y equals x cos x at x is equal to pi. Now this here is using your knowledge of gradients and the normal of a gradient. So obviously if the gradient's like that, the normal is going at a 90 degree, it's perpendicular. So you need to know the equation, which is m1 times m2 is equal to -1.
Yep.
We've already been given m1. Which is the first gradient, which we obviously got down here.
That's the equation of the curve, or the equation of the tangent.
At the tangent. So if we rewrite this with what we now know as well, it's -1 times m2 equals -1. So moving the -1 underneath the other -1, m2 is equal to 1.
Yes. So this would be the equation of the normal. Can you just put normal underneath that for me?
Yeah, I can. I'll just put it in here.
Yeah.
I'm going to put normal gradient.
and again it's a straight line.
Yep, so it's just perpendicular to the tangent that we worked out just a minute ago.
Yeah.
So from that, again, we're going to be using what we used here, which is y equals mx plus c.
The equation of a straight line.
And then from that, so now we know what m is, we know what x is. Again, it's exactly the same as last time, and now we need to try and work out what y is. So y, again, we're going to be using in this equation that we've been given here. So y equals x cos x, and it's going to be exactly the same as it was last time. So obviously cos x is going to be equal to -1, x is going to be equal to, so you move that into the pi's, so pi times cos pi, so I'll write that in there, slow down a little bit.
Pi times -1. Yep.
So then that equals pi times -1, which equals minus pi. Exactly the same answer as we got in the previous question here.
Yeah.
So again, we've got y, so now we need to try and work out what c is. So we put that over here. So you go minus pi equals, and now so you've got m2 is equal to 1, so you go 1 times pi plus c. So now we've got minus pi is equal to pi plus c, and then you move that across and that becomes minus 2 pi. So minus 2 pi equals c. So now we've worked out what the c is, we can now input it back into the y equals mx plus c equation for working out the normal. So if we come down here with this that we now know,
Yep.
y is equal to 1 times x in brackets plus minus 2 pi. And then obviously you just simplify it slightly, so y is equal to x minus 2 pi. And that there is your final answer.
And that is the equation of the normal.
That is the equation of the normal, the straight line that is the normal, which is obviously perpendicular to the tangent that we've
That's
got down
terrific,
halfway.
Lewis. Absolutely terrific piece of work. And a lovely little piece of, a lovely example of differentiating trigonometric functions using the product rule, a little bit of coordinate geometry, normals, tangents, radian measure,
Yep.
graphs, and pulling it all together in a lovely bit of algebra work as well.
Brilliant. Well, thank you guys for watching. Please feel free to watch this as many times as you want. And I'll see you guys in the next video. Thank you very much. Have a good one.